All right. So from your homework, should be very similar questions. So this idea, see how we have an asymptote at -6 and 6? So when you graph this guy, you're going to see these asymptotic lines where they can't cross and you will never touch. So from the right, or from the negative side rather, left side, if I approach 6, it shoots off, right? If I approach, I'm sorry, 6 is over here. So I approach 6 from the right, it goes to infinity. So the limit would be infinite. So now you would say just infinity. Okay. You won't say D and E or anything. You'll say, well, if it exists, it's just an infinite limit. Now, if these were different, if one was infinite and one was zero, you would say, oh, does not exist at that point. So the rules still apply for the definition. Like they have to be the same. Okay. Now, if they don't give you a picture, what you have to do, right? Let's just try to do this on paper just for fun, real quick. Where's my pen here? Okay. Let me write the question down, then I'll switch over. Infinite limits. All right, so let's say all you were giving was the limit of 2 times x over x squared minus 36 as x approaches 6 from the negative side. The the only work you could do is factor and notice that this is an asymptote. Really, is all we can do without graphing it. Could this be x minus 6, x plus 6? Let me switch over, like I said it would. 10, there we go, sorry. Okay, move this a bit. So there's not much work to do here. I really do advise you graph this. So when you factor the bottom, because it's a difference of squares, let me lower the brightness. You see that when x is 6, you get a division by 0. When x is -6, you get division by 0. So hence the limit at 6. So when you graph it, you'll see, okay, there's two asymptotes in these areas. And as we saw in the example here, right, we see we have two asymptotes there. So factoring the bottom will pretty much give you the clue, like, oh yeah, there's something going on here, right? Graphing in this makes it obvious. All right. This guy, number 2, is pretty much the same deal. You can see that plugging in a -2 makes a division by 0, right? So they start asking, well, what if we can't plug it in? What happens as I approach it using a limit from the negative side? So -2 is right here. So approaching the negative side, it goes down forever, right? Hence negative infinity. So this goes to negative infinity on the left side. On the right side, it shoots upward, giving you a positive infinity. So when this happens, you do have one-sided limits, but the limits are not the same, right? So
Mm-hmm.
technically, the regular limit would not exist, but the one-sided do. They are just not finite. Does that make sense?
Roughly.
So there's not much work to do here. Um, like on an exam, I'd say, well, I would probably just draw a sketch and say, well, as you can see from the left side, the function approaches infinity as it gets closer to the asymptote, right? Because that's what's happening. There's nothing else to say here. We can't do any algebra. There's no removable stuff. Nothing fancy.
Is it negative infinity because the exponent is a negative?
This direction is negative infinity, and this direction is positive.
But if we didn't have a graph like this,
Did
right?
not have a graph. You would plug in numbers closer and closer to -2, and you would see that it gets super negative, which gives you a hint that it is negative infinity.
Oh, okay, but like the exponent on -2, and then
This
it's a
minus thing,
yeah.
that's telling you that you're coming from the left side, negative
Oh,
side. So yeah, this has a plus coming from the right.
yeah. So that wouldn't tell me, right? Like if it was a negative infinity or not.
No, it doesn't. You could have this side shoot downward.
Okay.
So yeah, this doesn't imply anything. This only tells you which direction you're coming from. That's it.
Kind of like yeah, it's just an indicator
Yeah.
which way
So
you're going.
exactly. So from the right, from the left, and then you see graphically what's happening. All right, this is the same deal. Let's see. There's some problem where we actually have work to do. No, that's stupid.
Okay.
Here we go. This might be interesting. Nope, still graphing type. Still graph. Okay, so all these problems here are basically the same deal. They're just saying, all right, what happens from left and right? What happens left and right? So you graph this and you watch it. If you're able to plug it in, great. If you can't, well, you have to graph it. That is the easiest way to do it. The other way is this route, right? Remember how we talked about this? I think the first or second day. How I know I can't plug in -6, so I can get really close and see what's happening. But this guy is not really clear, right? So graphically, what's happening? -6 right here. From the right, it's shooting off pretty quick. From the left, it's shooting downward. So it's very similar to the last example. So this approach gives you somewhat of an idea what's happening, but it doesn't really imply infinity unless you put a lot of digits here. Like if you put like 10 zeros and then the one, -6.000, then you'll see that this gets really big. So it looks like it's going to 84, but it doesn't. So for these limits, you have to graph because when you have an asymptote, it's most likely going to be infinite type. And you guys remember asymptotes from college algebra, right? They are created whenever you have a factor on the bottom that creates division by 0. But yeah, so all these are similar, and you just have to graph them. Here, we have removable discontinuity. So number 11, there's actually work to do. Let's do that guy. So determine whether the graph of the function has a vertical asymptote. Or a removable discontinuity at x equal to -8. So it's still telling us to graph it, but the removable part we can do. Let me switch back over after I write the problem. F of x equals x squared minus 64 over x
So on
plus
a
8.
graph, this would be like a solid line with a hole, right?
Yeah, it'd be a hole that can be filled. But yeah, it's basically it. You're right. There's examples from the notes where we had removable because this guy can be factored with a difference of squares, right? Let me move that light a bit. I guess I can't. All right, whatever. That would be x plus 8 over x plus 8. So these cancel, leaving you with x minus 8. So the fact that that happens is say, yes, there is removable. Discontinuity at x equals negative 8. Now, if you couldn't remove it, then you would just say, yeah, there's an asymptote there. But let's go ahead and graph and see what it looks like. All right, it was x squared. Actually, I should put the fraction first. X squared minus 8, no, 64 actually, over x plus 8. So yeah, it looks like at age, right, as we get closer and closer to 8, it appears that we can fill it, right? But since we can factor it out, we don't have the asymptote. Like, for example, let's say this was something like this.
The hole would be at -8, right?
Oh, right. You're right. Let's check that first before I change the question. Thanks. Let's zoom out a bit. Should be. Yeah, I didn't get an error there. Yeah, undefined. There it is, the hole. I just can't see it on the picture. But anyway, yeah, so there is a hole, but there is no asymptote, right? As you can see. Asymptote will look like this. You see how there's a gap? So there's an asymptote going through the function at -8 here. So if it's not removable, and you have something that causes division by 0, you'd say, yeah, that's an asymptote at x equals -8, which I'm sure you remember from college algebra, right? Maybe.
Sort of. Yeah.
Yeah.
Kinda, it's been a while.
Yeah, it's all right. All right. Okay. You guys have any questions on those ideas so far? It's like, check this guy out. You can't factor the top, so it's not removable because it doesn't cancel, like we did on the paper on the other example. This guy factored and canceled, therefore it was removable. This one does not have that happen.
Or 13, we'll just
Here, you just look at it and see what's going on. Let's try it out. So 1 over x squared minus 64, right?
Yeah.
So look at it, right? There's an asymptote there. The limit does not exist, but it does exist from one side or from either side, just not both sides. So where's that questions at? Is it here? No, there it is. Can you see this?
Yeah.
Okay, so it says from the right. So from the right, it's going to shooting off to negative infinity, right?
Hmm.
See how it never gets to -8, no matter what.
Yeah.
So it's going to keep happening forever. You can try it out for 10 hours if you want. Not going to happen.
So how would we know like if it's negative infinity because we're going like two different ways?
Because you're going downward to the negative. Remember, the limits are talking about the y value, right?
Yeah.
So what's happening to the y value as I try to approach -8, right? See how it shoots downward? So the
Oh.
y, we're looking at the y the entire time.
Why though? No, I'm just kidding.
We're approaching x and we're looking at what's happening to the y value, the functional value. That's what we're doing. Okay. So
And
then
it's approaching 8 on the left.
left. Yeah, was I doing right? So left, let's see, zoom back in. -8 from the left would be infinity. Was it -8 or positive? +8, but from the left side. Sorry, I got all dyslexic. My bad. So there's 8 on the left side, -infinity. There we go. Sorry, guys. Does that make sense though?
Yeah.
So yeah, a lot of these you're just gonna graph and observe what is happening and what does it mean. So these are all just more conceptual. So you need to understand like how do I find one-sided? How do I find two-sided? When does it exist? When does it not exist? And what are asymptotes? So those are the things you need to make sure you understand for
For the test, are
2.5.
we going to be allowed to use? Sorry, are we going to be allowed to use that Desmos or?
I
like
do
graph and
want you to use
calculator?
that, yes, if you want to.
Okay.
I just need to figure out
Is
how to
is
let you
responding
use
that's
it.
what I'm gonna ask. Okay.
There is a way. I just need to figure it out as soon as possible. If not, I'll have to let you use it elsewhere or something. But we'll figure it out.
So if we're asked a question like that on the test, how would you want us to show our work? Just graph it?
Yeah, I would do like a little sketch and just explain like as I approach from the left side, the function goes to -infinity, and that's it. There's nothing else to say
Okay.
really.
Yeah, sounds good. That's what the lady was doing in the video. She was saying that if you're gonna prove it with a graph, sketch it. But I was making sure that if that's what you wanted as well.
Yeah. And I posted the
Okay.
2.5 video too. I don't know if you could see it earlier or not.
Okay, sounds good. Thank you.
Okay. You guys have any homework questions? That's pretty much your 2.5. I thought there was more stuff, but it doesn't seem like it. You guys have any issues with 2.4, 2.3?
I got that one question with 2.4.
Oh yeah, that's right. Let's just do it.
1 second, let me pull it up.
But we don't
Uh,
have for homework for 2.5, correct? It's just 2.3, 2.4.
Oh, this is
No,
the
2.5
2.5
homework's open. Yeah, it's open.
This is what
Oh.
we're talking about right now. This is all 2.5.
Oh. Okay.
Okay. The one I'm stuck on is 2.4 problem number 2.
2.4, problem number 2.
Part C, I think it is.
C. Oh, okay. Yeah, I remember this. Remember we said if the limit from the left and the limit from the right are the same, then the limit in general will exist. So from the right, as I approach C being -5, right? So here's -5. As I approach from the right, it's approaching the y value 5, right? Here's 5. Approach from the left, same deal. There's my y value. So since the limit from right and left are the same, that means that the actual limit is also 5. If one of these are different, this does not exist.
Oh, okay. Okay, that answered the whole. Okay. I thought it wasn't existing. I got thrown off by the iconography.
Yeah, it's not continuous, but the limit does exist.
Okay, that's where I got mixed up. I was doing limit instead of
It's all right. As long as it makes sense now.
Yeah, no, I think I got it. And that wraps up my 2-4 entirely.
Cool. Anyone else have any other questions?
I have a question.
Okay. Which one?
For 2.3, number 11,
2-3, number 11. Let's look at it. This guy?
yes.
Yeah. Does yours have different numbers? We can do yours if you like.
The only difference is instead of 8, it's 7.
All right. We'll change to 7. It's fine. So the limit is cosine 7 theta times tangent of 7 theta over. I'll switch to the screen in a second. Just give me a moment. Okay. So what we're trying to do basically is make it look like this. Remember how we have those special limits I told you to write down on a formula card or whatever? Sine theta over theta is equal to, I believe it's 1.
Yeah.
So when you're trying to make it look like this or something similar to this. So right now we just have a bunch of stuff. So we got to do our pre-cal to help us fix it and make it. Pre-cal and algebra will allow us to use this. So let's try to get there. So I'm going to change tangent into sine 7 theta over cosine 7 theta. You agree that's the same as tangent, right?
Yes.
So now you have cosine theta times sine 7 theta over cosine 7 theta. They will cancel, right? Because it's kind of like we have 2 times 1/2, right? This will cancel, correct?
Yeah.
So these are gone. So now I have theta approaching 0. We have sine of 7 theta over theta. So it's almost like this, right?
Yeah.
So all I need is a 7 down here, and I'm good. So what I'm going to do is introduce a 7 by multiplying the top and bottom by 7.
Can you scroll down just a little bit?
You see what I mean?
Yeah, that makes sense.
So once we're there, this 7 on top is not really doing anything. So I'm going to pull that out in front, just so you can see it clear. So now I have sine of 7 theta over 7 theta, right? Because this would be 7 times theta.
Yeah.
This 7, I just pull it out here because we are able to do that with the property of limits. So now this right here can be, you can use a special property. So this will become 1. Does that make sense?
Yeah, that makes sense.
All right, cool. So yeah, you just need to use your pre-cal and a little bit of algebra, and you can do it.
Can you move your
Oh,
paper down just a little bit?
Don't you also need to make the theta underneath the limit 7 as well?
Yeah, that's why I multiply by 7
Yeah.
here.
No, like actually underneath like lim 7 theta over 0. Because I was kind of like, whenever in the video she was doing that, she kind of didn't explain why, but she just said that sine, the numerator denominator and underneath the limit has to be 7 theta. Like in this
Yeah,
case.
these need to be the same. This one, and you don't have to worry about.
Yeah, I don't know if you would take off points, like if we just wrote theta or x in other cases.
No, it's fine. As long as I know that you're saying this will go to 0. Because
Okay,
it'll be the same deal, right? Because it'll multiply by the 7 anyway. So I'm not gonna get picky about it.
Yeah, I got you. Yeah, that's what I was kind of wondering whenever I was watching the videos. I was like,
Did she put a 7
right?
here?
Yeah, she was saying that like that where you just pointed and the numerator and denominator all had to be the same in order for you to make it 1.
Yeah, for sure these have to be. This one is more of a notational thing. Like it's more proper to put a 7 there, but it doesn't really change anything. This has to be done. You have no choice.
Yeah, and that was gonna be my next question. It was just proper, but I mean, I didn't want points taken off for something just so tiny, you know.
No, I wouldn't do that. As long
Alright,
as
cool.
your steps are good and your ideas are there, that's what matters. But yeah, we can put it on there. It's fine either way.
All right, cool.
So that brings up my question. So for our little like function card,
Yes,
are we able to put like the property or limits like rules on there, things like
you're
that?
allowed to put definitions, properties, formulas, theorems,
There's no examples, right?
but no examples, right?
Okay. Thank you.
And then you
So
can
if I
do
wanted to use,
oh, what's up?
sorry. So if I wanted to use like all the theorems from all the videos, I could, or does it have to fit on like a single note card?
No, you can put it on a page, front and back is fine. I mean, I don't think you need a page. There's not that many, but you can.
Yeah.
Just one page, put all your limit stuff and definitions. That's fine. Just make sure you show it to the camera and then scan it, and it's no big deal.
Yeah, for sure.
I know my teachers didn't let me use any notes or any formulas, but I won't do that to you.
Yeah, I've never had anybody actually allow me to use notes or formulas, but I appreciate it.
Yeah, I prefer you spend the time understanding instead of memorizing formulas.
How many questions? Like roughly, like
Let me look at it. I forgot already. Let's see here. I should
Share-
probably like.
don't be shy.
What's up?
And share your screen. Don't be shy. We won't
Let's see
look.
here. Yeah, don't trust you guys at all, man. Let's see here.
We won't look.
It is 200 questions.
Mm? Oh.
Just 10. There's only 10. That's it.
That's what they say, and then they have like parts to it. They're just kidding.
Each one has part A through Z.
Mm.
No big deal.
What?
Nah, they're very similar to homework questions. There is a little bit. I mean, there is a. I mean, this entire chapter is very theoretical. So make sure you understand the definitions, the concepts, because that's what. It's the best way to do well on this test. But they will be similar to homeworks and things we talked about. But I don't want you to get stuck because you forgot some of the ideas. Let's see here. I'm not gonna. There's 2 questions at the end that I'm not going to grade. If you do them, there'll be extra credit. But we're not. I haven't talked about it, so 9,
Like-
10.
Somebody asked if it was timed.
Oh yes, it will be timed. Let me see. You have 10 minutes.
Really?
So it's 10 questions. You got 1 minute per question. No, just
Just
kidding,
make sure to not blink.
Now it's 90 minutes.
So wait, it is 10 questions.
Yes, but the last 2 are bonus. So it's only 8 questions.
And it's 90 minutes.
Yes.
Wow. Okay.
So it shouldn't be very. It's not. I mean, it's not like crazy hard, but you do need to study and practice and understand the concept. The next test will be more problem solving, like factor this or do this, use this formula. But this one's more like conceptual and theory. So make sure you read and write notes on the videos and go over your homework. Okay. I'm not saying it's hard, but I'm not saying it's easy either.
So it's not going to be really just answering equations. It's going to be remembering
Yeah, it'll
the
be like
theorems.
it'll be mainly like find the limit of this, but there might be a question or two where it's like, well, you know, is it continuous? And you have to understand what does that mean, right? 90 minutes.
Okay. Yeah.
Okay.
All right.
That's all I have for you today. Do you guys have any other questions?
Did you get my letter from the ADA office?
Yeah, I'll make sure to make adjustments.
Okay, just double checking.
No, you're good.
Did you ever hear back from the other instructor about the book?
Yeah, he says he's looking into it. He has not told me yet. He says he thinks so. But as soon as I know, I'll remind him again. He probably forgot. But dude, that weirdo.
Albert?
No, I asked Pete.
Oh, that's right, yeah.
But I might just call instead if he takes too long.
Yeah, he has that bad habit, don't forget.
Yeah. But if I look inside in the homework, did you see anything about getting or paying for an ebook or something like that when you're logged in? Because it's usually if it exists, it should be in there, and if it doesn't, then there might. If it's not in there, then I have no idea until he tells me.
What would you do if you were given a function similar to the one we answered last, but it was like a fraction, like 5/6? There was one on the homework like that. And
5/6, like the trig one.
Yeah, like the trig one.
Like if it was instead of 7, it was a fraction.
Yeah. Sine 5, and then below, it would be 6 theta.
So something like the limit sine 5 theta.
Yeah.
Over 6.
6. Yeah.
You have to use fractions to help you out. So you do know we need a 5 down here, right?
For sure, yeah.
So what we could do is introduce 5/5, but not multiply it out. And I'm going to pull that 6 out of my way and show you what I'm talking about. So you'd have 5 sine of 5 theta over 5. And I can pull this 5 out there too, and then take the limit. No, man, my pen's all stupid. So then just take the limit of this guy, and your answer would be 5/6, right? And that's it.
Oh.
Yeah, don't let the fractions or weird numbers mess with you. Just remember you can pull stuff out and introduce whatever you want, as long as it's not 0. If you have no more questions, you're welcome to head out. And if you do, please let me know.
All right.
Bye, everybody.
See you later.
Yeah.
Hello, Mr. Gonzalez.
Is it
ya.
okay? Because I don't really know how to describe it too well what it is, but can I just share my screen and show you?
Sure, yeah.
If that's okay. Okay. I'm only asking because I have a subscription and you disabled this year.
Oh, let me turn it on. Sorry, hold on.
And
Yeah,
you
try it
popped
now.
up. Okay, but I don't know. Can you guys see?
Yeah, I see it.
Okay, sweet. So it's pretty much like kind of like the classes that we have, but
Okay.
the book that we have, it's a different. But I looked up your class. It says you have morning classes. I don't know if that's true, so I just clicked on one of those, and they don't have the book for this semester. But I wanted to know if you knew like what it was. I'll click on something.
I don't know. I could be just another guy named Gonzalez, man. I don't know. I don't know.
But it's
I think it's an
just,
uncommon name.
Yeah.
Yeah, that's true. I mean, no, it has your full name and everything in the
Really?
class schedule. That's all. I was like, I don't think he has morning classes, but I clicked. I was just checking.
No, I
Um,
don't. I don't have any morning. And I've never used Clutch, so I'm actually quite surprised why it's in there. It's weird.
so
Strange.
confused. But they don't have our book, and I wanted to know. I'm using.
Hmm. I mean, the concepts will be the same.
Just in a different order, maybe.
Yeah, I mean, the idea of limits doesn't change. I mean, it's the same stuff for a few hundred years. So
Okay. Because I was a little worried about that, but
they might
it's
have more depth
videos.
or more examples on different parts of limits, but it
Yeah,
shouldn't
it's
be.
broken down a lot more
Mhm.
for people that are slow like me.
It's all right.
So, and then
I'm a little slow too.
I couldn't download the syllabus, so it's. I don't know if any of you guys want to try it out for any of your other classes.
You like it so far?
Yeah, I've been using it for past couple semesters, mainly for my science courses. But
Mhm.
then I realized they had calculus and I think pre-cal on here, so I I use it for that. But it's pretty much a little like it's more step by step. So they'll give you a concept and they'll go over that, and then you have like practice problems.
Yeah, it looks like they add some more algebra to refresh you a little bit.
Yeah.
It looks, yeah, I'm looking at it right now. It's so they'll reintroduce stuff from college algebra and then bring in the calculus a little bit, which is pretty
Yeah.
cool.
So I don't know if any of you guys, if you're still on, if you want to try that.